Good morning, grade 12 students. And in this session, we're going to continue what we have started before about the genetics chapter revision. And here we move to question number two in genetics. Question number two, where document one represents the pedigree of the family members, where the members that are figured in black, they are affected by a disease. This disease is called cystic fibrosis. It's a hereditary disease manifested by respiratory and digestive troubles. This disease is determined by a mutant allele of a gene called CF. This gene is located on chromosome number 7. So they said that the gene of the disease is located by, or the gene that causes the disease, if it's mutated, it's located on the chromosome number 7. So it's found on the chromosome number 7. So what is the type of the disease? It's sex-linked or it is autosomal. So first of all, I have to think like this. This gene is located on chromosome number 7, so it's autosomal, since it's found on the autosomes from chromosome number 1, pair number 1 to pair number 22. So this is an autosomal disease. And they said that this gene is determined by a mutant allele. So we have mutation of the allele of the gene called CF. This gene is located on chromosome number 7. Also, they mentioned that the gene is very close to a non-coding region that has restriction sites. These restriction sites, they are recognized by the restriction enzyme TAC1. So first of all, we determined that the gene is located on chromosome number 7. So this is autosomal disease. Second, we have restriction sites that are recognized by the restriction enzyme TAC1. Here I'm trying to give you the hints or some of the notes how to read the question, how to start step by step to analyze it before you solve. Most of you don't read the text, or even you read it quickly in order to finish. And this will waste a lot of time later on wherever you are going to solve the exercise. So reading the text carefully, analyzing it, writing some notes on a draft, this will help you a lot during any of the exercises. So the non-coding region close to the functional dominant allele N. So they said that dominant allele N, it's the dominant one. So the allele of the disease is going to be recessive. It has 4 restriction sites for the enzyme TAC1, while the non-coding region close to the mutated recessive allele D. So they gave you the allele of the disease, it's recessive, of symbol D small, has 3 restriction sites. So the length of the restriction fragments is expressed in kilobase in document 2. So before I start with the exercise, first of all, I determined that it's located on chromosome number 7. So it's autosomal since it's found on the autosomes in chromosome number 7. Then they said that the functional is the dominant allele. So the normal is the dominant of symbol, they gave it an capital. And the allele of the disease, it's recessive of symbol the small one. They told you that the functional dominant allele has 4 restriction sites, and the non-coding region close to the mutated, it has 3 restriction sites. So here they determined the number of restriction sites for each of the normal and for the mutated one. The length of each fragment, they are shown in document 2 in kilobase. Before we go to document 2, let's move to document 1. In document 1, what did you want? In document 1, they show the pedigree. Here we have family members 1 1, 1 2, 1 1, 1 2, 1 3, and 1 4. So these are the whole family members 1 1, 1 2, 1 3, and 1 4. Here we have 2 1, 2 2, 2 3, 2 4, 2 5, and so on. And 3 1 and the 3 2, which is the fetus. So first of all, you have to know that the white circle is for the normal woman, and the white box for a normal man. Affected woman, affected man that are in black. These said indicate the possible genotypes of the individuals. 2-4 and 2-5 justify your answer. Yes, I want to hear from you. 2-4 and 2-5. First of all, we said that the normal it has the allele M, and the affected or the disease has the allele B small. Okay, so first of all, I want to hear from you. What is the genotype of the individuals? 2-4 and 2-5. 2-4 and 2-5. What is the genotype? Yes, I want to move to Summer. What do you think, Summer? What is the genotype of the individuals 2-4 and 2-5? First of all, I have to think, Summer, if they are affected or if they are normal.
They're normal.
Normal. So first of all, I think they are normal. So sure, 100% they have the allele N capital, since it's for the normal. So sure they have the allele N. Okay? But the second allele, it is N capital or D small?
D small.
D small. Why? Justify your answer. Yes. They are normal. So surely they have the N. But the second one, we can determine whether it's N capital or D small, yes, Samar. Why? Because they didn't give birth either to normal children. So they either can be an N, or they can be, each one of them, they can be an D. We have two possibilities. Maybe they have inherited N from each of their parents, or maybe they are an N or an D. This is the first part. Part two, or part B. We said determine the genetic risk of the couples 2-4 and 2-5 to have an affected or to have a sick child. First of all, the probability to be heterozygous, it's 2 over 3. So probability to be heterozygous, it's 2 over 3. For the man to be heterozygous and for the female to be heterozygous. So to be ND, it's 2 over 3 already. We solved this and we discussed this before. So 2 over 3. So for the man to be heterozygous for the 2-4. And probability for 2-5 to be heterozygous, it's also 2 over 3. And the probability to have an affected child, it's 1 over 4. So here, the genetic risk. So we can cross it, so it's 2 times 2, 4, 4 over 3 times the 3, 9, times 4, it's 36. So here divided by 4, it's 1, and divided by 4, it's 9. So the genetic risk will be 1 over 9. From where did I get 2 over 3? 2 over 3, it's the probability to be heterozygous for the man. 2 over 3, probability for the woman to be heterozygous times probability of the fetus to be affected. So it's 2 over 3 times 2 over 3 times 1 over 4. So I multiply the numerator, 2 times 2 times 1, so it's 4 over 3 times 3 times 4, so it's 9 times 4, it's 36. So the probability or the risk is going to be 1 over 9. Here I finished the first two parts. Let's now move to document 2. Document 2, they said that it shows what? They said the non-coding region close to the functional dominant allele has 4 restriction sites for the enzyme TAC1. So it has 4 restriction sites. However, the mutated, it shows only 2, 2 of these. So here for C, they said specify. Specify the site at which the mutation took place. Document 2, justify your answer. So as you see here, we have in the normal allele we have three bands, for example, or 3 fragments. We have fragments of 1.2 kilobytes, of 1.4 kilobytes, and zero point 0.7 kilobytes. This is the gene CF of the allele M. This is the normal one. So it has three fragments. However, in the mutated one or the mutant allele, we have only two fragments. Fragment of 1.2, which is common between the normal and the mutant, while the fragment 2.1 kilobyte, it's not divided like in the case of the normal into 1.4 and the 0.7. So here the difference between these two. Here it's 1.2 and 2.1. So this fragment is 2.1, while in the normal it's divided into two fragments, 1.4 and 0.7. So this is the site of the mutation where it took place. Moving now to document 3. Document 3, it shows what? It shows the results of the electrophoresis of the restriction fragments that are obtained by Southern blot technique. This technique is done for individuals 2-4 and 2-5 and their children. 2-4 and 2-5 and their children. So 2-4 and 2-5 and their children. So first of all, I have to look to the bands, and according to the bands, I have to discuss whether they are homozygous or heterozygous. So here, the did gel electrophoresis or the electrophoresis of the restriction fragment by Thafer blood technique for the individuals 2-4 and 2-5 and their children in the 3-1 and 3-2, where 3-2 is going to be the fetus. After analyzing the obtained results, indicate the real genotype of the individuals 2-4, 2-5, and the fetus as well. And part E, yes, based on the above analysis, did this couple and risk of having affected children justify your answer? So first of all, let's look to document 3, Selena. What do you think about 2-4? It has what bands and they are thick or not, and what do you think about their genotype?
What's the question?
What do you think about the genotype of the individual 2-4? You have, Selena, you have to use the document 2 as well. You have to look to the number of the fragments or to the size of the fragments. Since in the document 3 we are observing the size of the fragment 2.1 kilobyte, 1.4, 1.2, and 0.7. So these you have to compare them to document 2 in order to know if they have two normal alleles or one normal, one affected, and so on. Okay?
Okay.
So first of all, let's start with
So,
2-4 years, Elena.
okay. They have thick bands on 1.4, 1.2, and 0.7.
Very good. So they have thick bands, and you have two bands or two fragments of 1.4 kilobytes and 1.2 kilobytes and 0.7 kilobytes. So here, these bands, they correspond to the normal or to the mutant one,
Normal.
to the normal. So their genotype should be what?
NN.
Very good. So this one should be NN 2-4. What do you think about 2-5?
It has a single fragment on 2.1.
Okay, so 2.1. So whenever they have the 2.1, first of all, pay attention, all of you. Whenever they have the 2.1, 2.1 is exclusive for what? For the mutants, right? So here they have the allele of the mutant, or the mutated allele. And they have 1.4, also they have the 1.2, and they have a 0.7. So what is the genotype should be here? It should be N, and here it's N, N. Okay, moving now to 3-1. 3-1, it has thick bands on the fragments 1.4 kilobase, 1.2, and 0.7, which are the same as the normal. So 3-1 is going to be M, M. However, 3-2, it has one band of 2.1 kilobase. So sure, it has the allele D small, and it has one thick band at allele 1.2. It has 1.4, and it has 0.7. So sure, this individual will be MD. How it would be DD if it has thick band 2.1 and it has thick band 1.2. So here it will be DD. So here it's ND. So the fetus will be normal. So based on these analyses, is this couple as risk of having affected children? No. Why? Because according to this father God, both of them they have the normal allele. They have the normal allele. They have the fragments that correspond to the normal allele, and there is no chance to have the affected alleles as in recessive case. So here, as we saw, so we said 2, 4, and 2, 5. Either they are an M or ND. Why? Somebody was going to ask, Mr. You didn't give symbols or you didn't determine the dominant and the recessive allele. They already did in the question. They already did in the question, so no need in order to write them again. They determined and they gave you the dominant and the recessive allele as well. So 2, 4, and 2, 5, they are an N or ND. Why? Because since they are phenotypically normal, each should have a dominant allele N and another allele that can be neither an or ND. They said the one due to calculate the risk for the couples 2, 4, and 2, 5 to have an affected children or a mutant individual. So 2, 4, and 2, 5, they have the normal phenotype. And for each of the two parents to be heterozygous, the probability or the risk is 2 over 3, as we said before. So for the father, 2 over 3. For the mother, it's 2 over 3. So it's 2 over 3 times 2 over 3 times probability for the child to be affected. It's 1 over 4. So 2 over 3 times 2 over 3 times 1 over 4. So it will be 1 over 9 as we did. Part C, they said where does the mutation occur? The mutation has occurred at the site between 1.4 kilobase and 0.7 kilobase. So here, the mutant allele chose one fragment of 2.1 kilobase and instead of two fragments, 0.4 and 0.7, 1.4 and 0.7, sorry. So this explains the mutation site. Here, without this justification, you won't get any of the mark. So you have to justify your answer. For example, if you said only the mutation occurs between the site 1.4 and 0.7 only, you won't take the mark. So you have to justify the answer. Moving to part D, 2,4 has two of each fragment, 1.4, 1.2, and 0.7. So these fragments correspond to the normal allele. So this individual has two fragments that are normal and N, so it has genotype and N, and it's normal. 2,5 has one fragment 2.1 kilobase and 1.2 kilobase, which correspond to the mutant, and the fragments 1.4, 1.2, and 0.7 that correspond to the normal. So it has one allele normal and one allele mutant, so the genotype will be ND. Fetus 3.2. This fetus 3.2 has a fragment 2.1 kilobase, which implies that he received the mutant gene from his mother. He also have fragments 1.4, 1.2, and 0.7 that correspond to the normal allele that he received from his father. Thus, he will be normal heterozygous, having the genotype ND. So this individual has ND. So here in the question, they didn't want the genotype of the individual 3-1, but already we did this. So we already did this. But here in the question, they need only 2,4, 2,5, and that of the fetus 3-2. They have to pay attention in the quiz or in the exam, not to waste your time on doing the 3-1 since they don't need it. But already we solve it in order to determine how to use the Thaufel plot technique and how to analyze it. Based on the above analysis, is this couple in risk of having an affected children? Justify your answer. Justifying your answer, no. Why? Because 2,4 is normal and it's homozygous. So it's NN. So NN, it will transmit N for his children or for the children.
So an it's dominant. So whenever they inherit an or the from their mother, so they will be normal. No, because the two parents are not heterozygous, and the father 2-4 who is homozygous for the normal. So it's homozygous for the normal. It will give only one type of gametes, which is an. So it has an, which is transmitted to one of the children. So whenever they inherit from their mother an or the, so it will be either an or the fetus will be ND. So both cases, MN or ND, it will be normal. Why? Because the dominant is expressed in both homozygous or heterozygous, and this can be explained by the case that this person is homozygous or can be heterozygous, having the genotype NN or ND. So in this question, we determine how to use the the Thousand Blood technique and how to relate it to the restriction map here that is shown in document 2. And we determined using the pedigree to determine whether the allele is dominant or recessive, already mentioned in text. But if they ask a question here, if they add a question and they didn't mention in the text that is found on chromosome number 7, the gene for this disease, if they said you have to discuss logically the chromosomal localization of the gene causing for this disease. First of all, I looked at the pedigree. Males and females, they are affected. Males and females, they are affected, so it's not the case where both of them they have equal probability. So here, let's start step by step. If the gene is located on the non-homologous region of Y, none of the girls should be affected. But we have 2, 1, and 2, 3, they are affected. So it's not the case. So here I deny it on the Y. If I have to deny it on the X, every affected individual they have affected father. For example, here fetus, an individual here, it has XY. If it's on the X, so it has XDY. Okay? And here the female, it's XD, XD. So this every affected daughter should have an affected father. So each XD will be inherited from the father or from the mother. So here the father should be XDY and the mother should be XD and here other allele will be XD, XN for example. So here about XDY, the father will be affected. So it's not the case. So here I deny it on both X, non-homologous part of X, and non-homologous part of Y. Let's deny it on the homologous part of X and Y. If I want to deny it on the homologous region of X and Y, so here the denied for this individual XDYD. So this individual would be XDYD, for example, XDYD. Okay, so XDYD and here mostly you can deny it on both X and Y since the pedigree is very small, so you have to see more individuals, but mostly it's going to be autosomal. So finally we reach the autosomal, and you have to study it by the way that the cystic fibrosis disease it's autosomal. So whenever you have cystic fibrosis, always we solve about this, and this is an autosomal disease because it's located on the autosomes. So here we finish this question. This question, if it's in the official exam or in the trial is later on in school, this question is about 5 to 6 marks, 5 over 20. So over 100, it's going to be about 25 or it's about, for example, 30 mark over 100. So this is half of the mark is going to be based on this question, which is very easy. And we solved a lot of this question, even though we solved harder question than this before during the genetics chapter. So here we finished the session related to this revision. So every revision, every session, I'm going to discuss with you some of the questions related to genetics to talk about these questions and to discuss them together.